Hello YouTube, day 17. Let's get started. So, as your flight slowly drifts through the sky, the elves at the Mythical Information Bureau, MIB, at the North Pole contact you. They'd like some help debugging a malfunctioning experimental energy source aboard of their super secret imaging satellites. The experimental energy source is based on cutting-edge technology, a set of Conway cubes contained in a pocket dimension. Oh god. When you hear it's having problems, you can help agree to take a look. The pocket dimension contains an infinite three-dimensional grid. Oh god. Oh no. This is a 3D game of life. Oh no. At every integer three-dimensional coordinate, x, y, z, there exists a single cube which is either active or inactive. In the initial state of the pocket dimension, almost all cubes start inactive. The only exception to this is a small flat region of cubes, your puzzle input. The cubes in this region start in the specified active or inactive state. The energy source proceeds to boot up by executing 6 cycles. Each cube only ever considers its neighbors, okay. Any of the 26 other cubes where they differ by 1 coordinate, okay. Well, no, by 1 point in whatever coordinate, 1 unit. During a cycle, all cubes simultaneously change their state according to the following rules. If the cube is inactive and exactly 2 or 3 of its neighbors are also active, the cube remains active. Otherwise, the cube becomes inactive. If the cube is inactive, but exactly 3 of its neighbors are active, the cube becomes active. Otherwise, the cube remains inactive. The engineers responsible for this experimental energy source would like you to simulate the pocket dimension and determine what the configuration of cubes should be at the end of the 6-cycle boot process. For example, consider the following initial state. Even though the pocket dimension is 3-dimensional, this initial state represents a small 2-dimensional slice of it. In particular, this initial state defines a 3x3x1 region of the 3-dimensional space. Simulating a few cycles from this initial state produces the following configurations, where the result of each cycle is shown layer by layer. Oh god. Okay, so this is a slice. I guess next tick, this slice evolves like this, but it also influences a slice before and a slice after. Oh god. Oh my god. After 2 cycles, yes, things spread, so your space becomes bigger. After the full 6-cycle boot process completes, 112 cubes are left in the active state. Starting with your given initial configuration, simulate 6 cycles. How many cubes are left in the active state after the 6th cycle? Good question. Okay, so the initial thought that I have in my mind is this is probably absolutely not worth implementing as a matrix, because I think like a 3D matrix without having like a proper multidimensional matrix type in Zig is not nice. But on top of that, the more dimensions, the more everything kind of becomes sparse naturally. So I'm absolutely ultra tempted to just use a hash map and poke at coordinates using my hash map. So we have this hash map. We inject the initial state in it, and then we basically iterate over the initial state to produce the next state. And the result basically will be that I'm just gonna have to check 26. I'm gonna have to do 26 checks into the hash map for each active point. Maybe having a matrix would allow me to be smarter about the search. Maybe I could be smarter about the search even with the hash map, but at least I'm not gonna iterate a bunch of empty spaces just to discover that they're empty. So like in this case, yeah. Another interesting idea could be to... No, nothing. Just one big hash map, maybe? I think this seems the best option. Let's get started. Let's see how it goes. So Sublime Text, where did I put my Advent of Code stuff? Here. Okay, 17. Let's grab the puzzle input. Oh, looks so cute and innocuous. Let's do const data equals this. And we can also do this, which is nice, I think. By the power of Zig. Nice. We have our data. Okay, so what's universe? Universe is... Okay, so here's the problem. This is interesting. How big is this thing gonna be? Like, how big are the coordinates going to be in 6 cycles? In 6 cycles, like, the coordinates cannot be... Any individual coordinate cannot be, like, super big, right? So, one thing that we could do is say each coordinate, maybe it's fits in, I don't know, in a U8, and so we have a U24 representing all 3 things, and then with bit mask. Or we could do, which would be more normal, I guess, a 3 of whatever U8s or like U16s probably, just to be sure we have enough space. 3 U16s, not too big. The problem is I need to understand how this interacts with the hash map. Although this is a value type, I think I might not be able to use auto hash map. I might be forced to have to explicitly define stuff because I'm not sure if the behavior with arrays is what I want. The reason why I was thinking about like kind of cheating and mixing all the 3 coordinates into a single big U number, it was just basically to make sure that the auto hash map would behave as expected. But hey, we can just take a look and see what it has. So auto hash map packed struct. No, that's a very bad idea. That's a very bad idea. Or maybe not, actually. Because, you know, it's not a bad idea because I don't care about size, honestly. I don't care about size. Like, even if it ends up being... Okay, but how do I fuck it. Packed struct it is. Matt, it's your fault if things go wrong. So we have X, U16. I don't know, maybe we'll have to increase those. X or Y, Z. Actually, does it even have to be a packed struct? I think it doesn't even have to be a packed struct. And do we want a auto array hash map? we are iterating over stuff, so that might be a good idea. So our keys are gonna be coordinates, and our values are gonna be bool. It's either dead or alive. So we have our type. Expected semicolon. Yes, I put on here. Stop annoying me. Okay, so we have our universe. Now we need to populate our universe. Wait a second. These are not U's. These are I's. These can go negative. Oh, yes. They absolutely are required to go negative. Should I just do I size and stop being cheap with, being stingy with bytes? Okay, then what else? We need to parse our thingies here, and let's do it. So var it equals std of mem.tokenize. What are we tokenizing? We are tokenizing. Do we need to give it a type to tokenize? I don't remember anymore. Maybe I should re-enable the LSP. I disabled LSP because it was giving me trouble with files. Expected. Yeah, dude, I'm typing. Okay, thank you. Mem tokenize. I don't get access. No, so I get annoyed by errors, but I don't get the autocomplete. God damn it. Data. And we want just to tokenize on a new line. So the idea is I'm just doing this so I can skip the new line. I don't have to think about the math of new lines. So while it.next, I get a line, and for each line I get a cell, and I need the coordinates of all these things. So line is gonna give me, let's call it the y coordinate. Let's say that cell is the x coordinate, and z in this case, since this is a 2D slice, z is gonna be 0 always in this case, I guess. So also I need an allocator. Because we need to give an allocator to that thing. So let's go grab an allocator here, please. Thank you. Expected pipe. Oh shit, I can't do this. Why is this so annoying? Okay. Why is this so annoying? I can't have y here. Oh. This is annoying. Okay, so we have a normal y, and I guess I'll have to do we can do this though. So we have y, which is an e size. It's gonna always be positive in this case, but I'm making it an e size so that the thing here doesn't complain. Although now that I think about it, the x is probably gonna be annoying. In any case, so as I was saying, each line we grab each cell. Now we try universe.put what a struct that contains dot x is x, dot y is y, dot z is 0. And that should be it. And for value, we put true. And actually, now that I think about it, we don't care about the value. Actually, it should not be a bool. It should be void, because the plan is we only keep in here real live stuff. When something is killed, we should delete it. Or should we? Maybe we should keep in there. It could be useful. No, because that would make us also loop over that stuff. And I think it's... Oh, this is interesting. So on one side, keeping this stuff in there might be useful so that we can reutilize memory without having to mess around every single time. But nah, let's do void. I like void. Okay, so we're putting in the universe the stuff. So we're initializing the stuff. Let me also put, oh God, sublime. Let me put this stuff inside our block, and we say, I would say that tokenize also should go in here. And we say init. Okay, so this is the space initialized. So next we need to apply the rules. We need to do 6 ticks, right? So var I equals usize equals 0. Var prev equals, we need to clone the hash map. Oh, can we do it? Do we have clone? Please. Why is LSP so annoying? So everything compiles. There's probably a programming error that is preventing LSP from doing the right thing. Okay, you know what? Let's try to compile this just to catch the programming errors that are inevitably there and see what happens. So AUC zig build day 17. Oops, no, day 17. Okay. Container std has no member auto array hash map. Is this uppercase? This would explain a bunch of problems. Oh yes, okay. So finally we get universe dot. No, okay, we're not. LSP is not happy either. Yes, x need to be casted to I size. Okay, so now everything seems good. Can't get the complete either. Okay. Let's go find in the standard library. Do I still have a standard library thing somewhere? No. So we were saying array hash map. What we care about right now is if there is a copy thing. Can we copy, please? Please, can I copy? Put a fetch contains move items clone. There we go. Clone, please. Thank you. Yes. Okay, so var prev is the universe, and next is a new one. And then while I is lower than 6, we need to simulate stuff. So I represents our like generation. And what we need to do is say, okay, we need to loop over for each on cell, compute new state, or apply rules. One thing to keep in mind, like one thing that I learned from the airport is to make sure to check inside prev for prev stuff and not try to read undefined memory. In this case, we're not gonna read undefined anything. We're just gonna end up not finding things because we are looking at an empty next. So it would be less annoying, I guess, than last time, but it would still be, well, not correct, but also not it would just give us wrong results, not produce errors. So so what we do is it is prev.iterator while it.next is old cell. Let's call it, actually, alt is the same concept as prev, so let's call it prev cell. So this is the state of the cell. This is an active cell that exists in prev. And we need to poke in it, around it, to the 26 pokes to know if we need to also put this cell in the next iteration. So how many cubes are left in the active state after the 6th cycle? So what we want to do is then, here's the rules. Okay, we need to poke all coordinates, so we need to generate all coordinates. How do we do this? Did somebody say metaprogramming? Comp time metaprogramming? Did I hear that? I think I heard comp time metaprogramming, so okay. I oblige. So const, I don't know. What did we call those in, what was airport? There we go, day 11, boom. Did state, what do we call those? Ops. I like ops. Okay, now the problem is that these operations. Oh no, this is not metaprogramming anymore. What happened? Oh no, I had a problem, I guess, somewhere. Oh god, no. We can make this. Okay. No more metaprogramming, normal, boring programming. So this is .x. This is .y. We need also .z. And I guess this can go. Oh man. So everything is -1. And this goes to 0. Oh, this is already too much. Is there a simpler way of doing this? Is there like a thing where you say like, please just whatever? So wait, no. Okay, let's do all the minus ones. The minus ones, minus one, then 0, then 1, then 0, 0, 0. Oh, ZigFMT is gonna murder my beautiful alignment. I think we can... I don't remember which is it. Zig dash FMT? No? Zig space FMT? No? Oh god. At one point in time I knew how to disable Zig format. Why not fill up via loop? Because thinking about if I had how to do this loop immediately in mind, I would do that. I don't know. I'm dumb, I guess. That's the answer. So we have -1, 0, 1, and then finally we can have 9 zeros here. So -1, -1, -1, -1, 0, 1, 0, 0, 0, 1, 1, 1. We should have everything. Oh god, I hope I'm not doing something dumb here. No, I think it should be fine. We have everything here. Finally, this is 1. Oh, guess what? Kind of important, this guy should not be there. Kind of important that this guy is not part of the list. Okay, so 3 minus 1s, 3 zeros. Okay, now this is much better. Yep. Okay, this is much better. Okay, now saving obliterates my alignment. I want to keep my alignment, so I'm gonna find out how you disable ZigFMT. I think it might be even in the docs. You know where I do this? I do this in OKRedis. I do this in OKRedis. I think I do this in like some of the parsers, like this maybe. No. Map. No, I don't have tests in here. Where did I put tests for those things? They put all tests down here? No. I did put some tests in here, that's for sure. But oh, there we go. Found it. So it's Zig FMT off. So I think it was a matter of spaces, maybe. Nice. Let's see. Nice. Yes. Okay. So we have the previous cell, and we need to count all the things. So var on. Well, let's call it just neighbors. Suzy equals 0. For each cell, then we do for ops an operation, and we do we should also do a sub. Let's do a sub function, well, public function sub self is a coordinate, other is a coordinate, and we return a coordinate, and the result is return dot x equals self dot x minus other dot x. C save. And that's pretty much it, I guess. So for each operation, we try to get, we do where do we get from prev dot get prev dot get prev cell. Why did I do sub? Why didn't you do sum? I don't know. Why was I thinking about subtraction instead of sum? I mean, at the end of the day, everything works out anyway. It's just weird that I had this in mind. And the other is the operation. So we had the operation, we try to get it from the hash map, and now the question is there? It's there. Neighbors plus 1, else. No else. Also, wait, we need to do like the unpacking, right? Because this gives us an optional. Although we can get a bool, I think, since we don't even care about getting anything from there. I think it has a, I think it contains. That's much easier. I think we can even be fancy, like neighbors plus equals bool to int prev dot contains prev cell dot add op. The close enough parentheses. Now I did. Yeah, we can even be fancy like this. Basically, we try to get information if it contains cell. If we do, boom, we add neighbors. Okay, so now finally we counted the neighbors, and we need to do the rule. So switch neighbors. Let's see what our cases were. A cube is active and exactly 2 or 3 of its neighbors are also active. The cube remains active. Fuck, I'm just realized that I'm a moron. If a cube is inactive, I just forgot to check its neighbors because I'm skipping inactive cubes. Oh god, this is so bad. If it's inactive, but exactly 3 of its neighbors are active, the cube becomes active. This is interesting. If it's inactive, it's lazy, it must be removed. Oh, this is interesting. I'm being punished for not thinking about this second rule. I was thinking about this first rule, and this thing solves the first rule very well. The problem is I'm missing the empty stuff. So there are 2 possibilities. Either I make empty stuff real, or somehow I learn how to make empty stuff materialize. But this is terrible. This is truly terrible. We could probably do that. So the idea is how to... So I'm not going to iterate over... Let's assume for a moment that I keep the current system and I don't switch to a full-blown matrix. Which, by the way, I could switch to a full-blown matrix also in the hash map. That would work. Kind of inefficient, but hey, that would work. So, and I'm genuinely starting to suspect that this whole 3D game of life problem, it might be, and we have yet to see part 2, right? And it might be that this problem is based on the idea that they might force us to, like, they might give us a input for the second part, or like ask us to do something for the second part that kind of blows up the entire space too much. So we do need a sparse representation at that point, regardless. You know, I'm kind of seriously tempted to just spin up find NumPy or something that gives me sparse matrices and say, fuck it. It's a sparse matrix implementation. I don't want to even think of the details. Just make it work. Anyway, so let's assume that I keep doing this sparse thing where I don't have empty spaces represented explicitly. One thing that I could do is I do this looping to know which of the existing things need to be shut down. But when I'm switching neighbors, if that neighbor is empty, I could add it to a temporary set of empty spaces that I should check if they can be turned on. That could work, because it's only one. The only shutdown spaces that can be turned on are the ones that are touching somewhere a block, a cube that was already turned on. So if instead of like ignoring them when I don't find a particular set of coordinates inside, I add them to a set of empty spaces to check later, and that should be reasonable. So let's do that. So I'm also add like an empties hash map, and here's what I do. So bar candidate cell, or whatever, let's just call it and cell, neighbor cell, I guess. That's the neighbor cell. if the neighbor cell is alive, then we increase neighbors. Else, empties dot put it in the empties one. Nice. Also, I think that this is a try put. I try putting stuff up here. Yes. So we put it inside empties. After we are done counting neighbors for this cell, okay, we do the neighbor switching. So we do the 2.3. So if it's between 2 and 3, what was it? Yeah, it's between 3, it becomes active. So we do try next dot put wait, I'm dumb. This and this is here. Expected arrow found dot. It's triple dot. Okay, so yep, for each cell, count the neighbors here. We switch over the rule. It's 2, 3. We put prev cell in next state, else nothing. That's the only situation where it survives. Once we are done with all the cells, take a peek at candidate. Take a peek at empty cells, see if they should turn on. Nice. So we can do the same thing basically. This time our iterator are the empties, and for each empty, count the neighbors by applying the operations to empty cell, and that's the same exact count. And then we switch over it, and the rule is if exactly 3 of its neighbors are alive, then this empty cell actually becomes real in the new world. And that is nasty. That's a lot of looping. That's a lot of double checking things. This clearly could be improved. This could be improved so much with a bit of smartness, but hey, what can you do? And with this, we have properly done our entire job. So the generation has been completed, and now we need to do the generational cleanup. So generational cleanup, which means empties needs to be reset. How do you clone, remove, assert, discard, remove, contains, get index, get entry, fetch, put, assume capacity, put no clobber, capacity, ensure capacity, get or put value, get or put, blah, 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 count, clear and free, clear retaining capacity. Oh, yes. Clear retaining capacity. Thank you. And then, here's the, oh my god, this trick is so dirty. I love it. So here's what we do. We do var temp. We copy. Oh, how do we do this? Basically, what I want is to swap these hash map thingies, but I don't think the hash map can be copied. Can we copy? Insertion order is preserved. Deletions perform a swap removal of entries on the entries list. Modifying the hash map while iterating is allowed. However, one must understand the well-defined behavior when mixing insertion and deletions with iteration. For a hash map that can be initialized directly, it does not start allocator fields unmanaged. When store hash is false, this data structure is biased toward chip equal functions. Blah 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 blah. Typical operations accept iteration entries, but need to be faster. Prefer the alternative hash map. How do we do this? How do we do? So here's the idea. What I want to do is basically I want to make basically prev. I want to remove the current prev and make the current next become prev. But I'm trying to do a bit of memory trickery where I don't want to like free all memory and do all this stuff. What I want to do is kind of refer now to next as prev and clean and move prev to next and clean it using this clean retaining capacity. So I need pointers. Or not necessarily, I don't necessarily need pointers, but I suspect that this struct cannot be copied. Although this doesn't say here that the struct cannot be copied. Maybe the struct can be copied. If the struct can be copied, we're good to go. Let me double check what's inside. Unmanaged, let's see the unmanaged things. General purpose table, insertion on the preserved, deletion, modifying the table, iterating is allowed. Can be initialized directly. It does not say that the struct cannot be copied. But inside it has an array list. And I don't know if array list can be copied. So the comment might not be saying what we need to know. See? A contiguous global list in memory is a wrap around the values. Struct contains items, slice, capacity, and allocate. I think we can make do without pointers because these structs can be copied. And if the structs can be copied, copying the struct doesn't copy the entire memory buffer behind the struct. Because the struct, it's a head that holds a pointer to all the memory occupied by the hash map. So let's hope that, you know what, maybe we should try this with the nice example input first. Just to make sure that everything works as expected. Maybe. Actually, let's YOLO once, and then we'll see. So temp is going to be, we temporarily copy prev. Then we say that prev equals next. And then we set next to prev. And then, well, and then we clean next. So this is the idea. We swap them. And why am I not using prev? Sorry, why am I using temp? God. Okay, here it should be using. 6 times. No, we should also do like print. Let's do a print so that we get a feeling if it's super slow, why it is super slow. And after 6 iterations, we need to count them, right? So I guess we do this. Over what? Over prev, right? Because at the end it's prev. Yes, at the end it's prev. So iterate over prev, and for each, and now we don't, well, we're not doing anything on this sort. It's just print final count equals something prev count, and that's it. So I wonder if this is a case where having a non-array hash map might be better. But let's fight the programming errors first and later. Type info, type of, blah 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 blah, function, turn, type, error, union, set, array, blah blah blah, hash map, hash array, hash map does not support field access. Okay. In other words, clone must be tried. Next, no member name add instruct std array hash map entry. Right. Is there like an iterator that just gives me keys directly so that I don't have to wrap stuff every single time? Right, hash map. Let's see. Iterator has next and reset. The init clear retaining capacity, clear and free count. Iterator, please. No. Okay, so for each of these iterator stuff, const empty set equals entry key. We need to do the same thing every time there is a entry. Oh god, entry. Okay, I'll get there. My overriding stuff, am I butchering names? No. Okay. The other place where this is happening doesn't look like it. This error message is gigantic. Redeclaration of variable IT. Thank you. Oh god, this was so long. You are indeed right. This is why I like blocks. Nice. Oh, wait. Okay, this is taking already way too long, but there's one thing that I'm forgetting, which is, so this is a while loop. This is a while on iterator. This is a next that, sorry, this is a for loop that only changes next and empties. Nice. This is a while loop on an iterator, on a for loop, only changes next. Oh no, I did remember to clean empties. Oh god, why is this? So this is generally this low period. Okay. What is it that I'm stressing so much? So the possibility could be that I'm creating too many. Hmm. Oh, you know what's going on? I know what's going on. I think I did also something stupid with parsing. When I'm parsing, look at this. I'm doing every cell, which is nice. I'm not even checking if that cell is on or not. Like, dude, what are you doing? Right? Let's nicer maybe. Let's be good people, and this could be here maybe. I think I want parentheses. Okay, so that's one thing that needs to be fixed, which ideally should solve a little bit. Like iteration, the first iteration should not take these, right? Okay, let's do some more printing. Actually, okay. So it's checking coordinate. Just a quick check. 600 0 1 2 3 4 5 6. Nice. Then 7. Then 1. Yes. 0 1 2 3 4 5. Okay, so these coordinates make sense. Um, oops. I should not be able to add duplicate coordinates, but I'm thinking that I might not be resetting empties correctly. Let me think about this. I'm collecting all on cells. So first I'm looking at all on cells. And for each, I'm adding all its dead neighbors as empties. Then I'm iterating over the empties. Oh, you know what? Also take a peek at how this is going. Just a ton of empty coordinates. Like a ton of empty coordinates. Also, we can also make this better. Instead of, oh god, look what I was doing. I'm not adding, like, what's going on here? Why am I dumb? Why did I not delete this stuff? So Code Monk, the way I'm addressing that is by nature of this being an hash map. So if I add the same item, the same key twice, the new key takes place of the old one. And actually, I mean, it doesn't even matter, like, whether it substitutes or it doesn't substitute. But like, you cannot have duplicates in a hash map. That's the whole point of using the hash map. Well, that's the whole point, but it's one of the points. Basically, since this is a hash map without values, or let's say void is the value, this behaves like a set. This is a set backed by a hash map, implemented over a hash map, basically. But the stupid thing that I was doing is that I didn't delete, when I copied the code over, I didn't delete these, which I suspect it was making everything weird and stupid. Yeah, look. Maybe this is not the right answer, but at least now it makes sense. So let's remove some of these. Okay, let's move this. Let's move this. Let's comment this. Might be useful to have this. Okay, so now it's like fast. The final count is 426. Can we trust this? It seems kind of low as a number. But hey, I don't know. Right answer. First try? Almost first try? I mean, what a dumb mistake to make. Like, copy pasting code is... it's a trap. So without copy pasting code, after recognizing the piece of code that should not have been copied, now everything works and it's nice. Part 2. For some reason, your simulated results don't match what the experimental energy source engineers expected. Apparently, the pocket dimension actually has 4 special dimensions, not 3. The pocket dimension contains an infinite 4-dimensional grid. Nice. So this is interesting. By adding another dimension, this is proving that the sparse approach was the key of solving the previous. It was, I think, useful, kind of important there, but here is even more so. Every time you add a new dimension, the sparseness increases exponentially. So that's good to know. So it's now a 4-dimensional thing. Oh, now, oh my god, look at the slices that we're given. Okay. The initial state of the pocket dimension still consists of one flat region of cubes. Furthermore, the same rules for cycle updating still apply. During each cycle, consider the number of active neighbors of each cube. Okay, so we just need to add a new dimension. Could this really be this easy? No! Put this thing here. This is where I'm being punished. My stupid table. I'm being punished for my stupid table. Ah! Stop suggesting stuff. Let me think. Oh, you know what we can do? This be a while or a bunch of fours? Make this also fours. Be better. Yeah, let's do it like this. Actually, I don't care. Okay, we're going full comp time. I don't care. Oh, wait, can I do it like this? Man, can I just append? I don't think I can append. Oh, this is annoying. How do I solve this in comp time? I don't think I can solve this. How can I? This is interesting. Uh, how do I solve this? This is genuinely interesting. I basically need a. It's like three. I guess this is, well, this is, sorry, this is an array of coordinates. Yes. And this is how big it is. It's 3 times 3 times 3 times 3, right? Or is it? I think it's, yeah, I think that's the thing. -1, actually. This is why I didn't want to do this before. God damn it. -1. And what we want to do is that if a equals 0 and b equals 0 and c equals 0 and d equals 0, we want to skip this loop. Otherwise, we need indices, I guess. I, the I, god damn it. And oh yeah, if I get all these indexes, this is gonna give me the index. Do I want this? No, you know what? Wait. Fuck these indices. No. Var I equals 0, and we increment I in here every single time at the end. Better, so that we don't encounter problems with these special casing of the 0, 0, 0 coordinate. And here what we do is say t addition I equals coordinate what? X equals A, Y equals B, Z equals C, W equals D. Expect a semicolon from this is of type this was undefined, and we break with and there is no this. Okay. Whoa. So this initializes our operations. Do we need to change anything else? No, in theory. YOLO. Oh yeah, no. Yeah, we're missing field W somewhere. Where? Oh, here, right. Nope. Nothing wrong there. Okay, you know what? Let's change this block thing into a function. Because I have a small suspicion that this thing is like this comp time block might not be working as I to work. We still have to do this thing. And then we return t. Unable to evaluate constant expression. Why are you unable? Oh yeah, right. Okay, and I think this is now okay. This is now working as expected, and it's complaining that I'm iterating over stuff that should be fine. Okay. Use of undeclared identifier I. Good point. Did I obliterate it? Okay, var I equals 0. I'm not specifying the type of I, by the way, because we are in comp time world, and I think is it needed? Okay, apparently must be const or comp time. Comp time. Okay, still not working as intended though. Let's see what's happening. I guess let's print the ops. Like instead of doing anything, let's just print the ops. Unreachable code. Oh. Ops.len. greater than 0, return. Are you happy now? Okay. Does this look right? I think it does. Right, maybe. There's a bunch of -1s, there's a bunch of zeros, there's a bunch of... God damn it. Did I really do that? I did do that. No, that's not it. That's it. Okay, so now it looks more. Yes. Many -1s. Okay, so now this should be fine. There we go. 1892. Slower, but it didn't take that long. Right answer. So I honestly don't have much feedback for today. I mean, everything made sense. Yes, I was punished for not wanting to compute the table first. I don't know why I wanted to do it manually. I think I was worried that computing it wrong would mess up, and I did end up computing it wrong actually first time, would somehow cause problems. I don't know also why I decided now to compute it at comp time. We could have computed it at runtime and almost nothing would have changed, but I don't know. Anyway, hey, it's there. Everything kind of worked pretty well. Worst thing that I did was copying the else branch here, and that had a weird interaction with the iterator and made everything loop forever. The result was like a bit computationally expensive, right? I mean, it's not super slow, but it's not super fast either. It did have to crunch a little bit, and that's interesting. But hey, everything worked out nicely. You got the correct way to represent the world right away. Yeah. I was smelling the... I guess these are the things where having a bit of experience with... I don't know, I did some of these things, I guess, when in university, when doing computer science. And I've done a little bit of data science. And I have... Like, I don't have... For example, I didn't catch on immediately that the bus algorithm would end up being super exponential in the naive version. I noticed because it wouldn't complete, but here I kind of was smelling that the space would be very very sparse, and that even though like this empties thing, it's very wasteful. Like or even like these two loops, they are very wasteful. They end up checking the same cell. They end up going over the same cell like twice or thrice, something like this. There are better ways of doing this thing that avoids all the repeat work, for sure. But at the same time, this is already still probably cutting away enough unnecessary work that it's worth it. So that was fun. And now that I think about it, so will you make a quick benchmark for your solution? I'm curious to see. My solution completes in about 0.3 seconds. I think mine is lower. Oh, well, wait. Also, Coinmonk, are you typing? Are you writing the solution in Zig or something else? Okay, in release fast, it's much faster. Hyperfine cache bin 17. Oh, yours in Go. Okay. Okay, in release mode, mine takes 75 milliseconds. You know what's interesting? Let's see if the array hash map was a bad idea. So let's make empties, and empties stays an array hash map because we only add to it, then we iterate over it, and then we clean it. So empties can stay an array hash map, but let's make next not an array hash map. Let's see if we gain or lose anything. So let me compile it. and let me hyperfine it. We lose. Well, maybe we lose. Yeah, I think we kind of lose a little bit. So array hash map ends up being better. Yeah, array hash map is a little bit better, apparently. So I would say this is like 73 to 81, 79 to 86. So it's 2 milliseconds better. I think among that in like, yeah, as Matt was saying, it depends on your algorithmic approach, I guess, a little bit. But there's also the fact that like I'm cheating in a sense because I'm using an arena allocator, and like this basically means that I don't pay allocation price for anything, basically. I think this stuff all fits inside a single page all the time. And that's it. Mine is a bit different. I saw the known universe and keeps track of the known limits. I see. So you do store the empty stuff. Yeah, I think that especially in the 4-dimensional case. In the 3-dimensional case, I'm not sure. Like the cut point is probably, it probably depends on the starting conditions and the rules. Basically, it depends on how much crowded that space ends up being. But in the 4-dimensional space, especially considering that the rules don't change, and that the rules also are not very flexible, right? Like it has to be between 2 and 3, and specifically 3 for something to turn on. Like these two rules are, by being fairly strict, basically it means that the 4-dimensional space is mostly empty all the time. And I think that this is then making a difference. So yeah. And yeah, and the empties, so the reason why the reasoning behind this, I said this earlier, but in case anybody missed it, the idea of empties is that in my hash maps, you won't find empty cells. You only find cells that are turned on. But we are poking at all of these coordinates while checking around cells that are turned on. And at the same time, you kind of need cells that are turned on for an empty to ever having a chance of coming, of turning on. So this allows me to basically collect a cutoff around each turned on cell to put in a temporary place so that I can check it later, and that solves the problem of not having these coordinates represented anywhere in my hash map. An alternative way could be that you whenever you're looping over a turned on cell, you do the stuff for the cell itself, but then here, instead of putting it inside empties and then doing the check later, here in line you do the checking immediately. The result is that you will do some extra useless work, I think. Yeah, that's another way of doing it. The problem is that with this, you will check the same empty slot multiple times, while this way, by virtue of empties being a set, you avoid doing this type of extra work. But again, it depends, because maybe depends on how costly it is to add something to this auto array hash map. Since our input data is not gigantic, again, I'm basically cheating by using an arena allocator that basically, I basically have a gigantic, I have a 4K bytes buffer that I keep using as dynamic memory, even though it's not dynamic memory, or at least it's like one big allocation, and then I keep using it for my stuff. And if the input was much bigger and we started having to be forced to actually use a real strategy allocation, and we start stressing allocation, we might get to a point where you might not want to do this and you would prefer to do a bit more CPU work to avoid memory work. I don't know if that makes sense. And maybe it's never going to be the case with this specific algorithm, but it can happen. That's just my point. Because sometimes it happens that doing more work in the CPU is worth it if you do less work with the memory. So this is something to keep in mind. Not our case here, but still possible. So I think I'm gonna call it a day because we have a Zig meeting in Discord coming up, I believe. Oh, this is your solution. Okay, I'll take a look before leaving. Let me see. Activation threshold, deactivation lower, deactivation threshold up, motion steps. Okay. Counter is a struct that has a counter function. Okay, pocket. Oh, okay, the pocket dimension. Oh, you do have a map too. Oh, you have the max and min, but you are storing the empties too, I imagine then. Oh, wait. And you're doing this. Right. Would you have a better way of doing it? Could you make a map where keys are arrays? You could have made a map with an array as key, right? Let me think. Okay, because I understand what you're doing. Oh, look at this. Okay, so you are doing the full loop to check and apply the rules. You know that I really think that you could have put here an array. You put an array of like an array of 3 ints as key. You should be able to do that in Go. If it's an array, not a slice. If it's a slice, I think slice probably don't work. Not even sure, but an array would make sense. I was worried to add overhead to the hashing function. Well, here's the idea though. If you put an array of 3 or 4 ints here as the key, again, this is something that you probably don't have. It's not easy for you to inspect because maps are built into the language. But normally, well, I would say smart hash map implementations, when they see that you're giving a int or a primitive type, like a array of 3 ints, they don't do hashing. They use the value itself as a hash. Let me see if I can pull up the relevant code in hash map. So we have auto hash map, right? That is a hash map that chooses the hashing function and the equality function automatically. So, okay, so the auto hash map, and like when you have like 3 ints, 4 ints, sorry, you just do equality. Like checking 4 ints for equality in the CPU is super fast. You should not worry about that. But let's take a look at what was happening in our case. So let's see what meta.equal between A and B is what ended up deciding how the equality function would behave with our packed structs. So need to go into meta, see what equal decides to do when the types passed in are structs. If the types are structs, it checks fields field by field. Oh, it checks field by field, and it uses itself, so it's recursive in the definition. So for each field, and then it picks, depending on the type, the case here. So yeah, like for arrays, that's how it works. Just yeah, it just loops over. Let's see, for where is in our case, so we had a struct and all our fields were numbers. So else case. So yes, in our case, it would do equals equals, which is like CPU check for equality, and for each of our fields. So basically, that's as efficient as it could get. That was in our case for the struct, Zig chose I guess the perfect hashing function. So that was fine. And if I passed in an array, it would have done also the same. It would have done also do it the proper way, because it would iterate for each element and then apply like find also itself, which and would end up being equal. So yep, both of these things are very much fine. I think that's it. Yeah, I think that if unless you hit a problem with Go's type system that for some reason doesn't want you to put arrays in here, it should help you with everything, right? Because at that point you don't have to think about weird hashing functions and going from one to the other, back and forth, and whatnot. Yeah. So, and you use boundaries to know when to stop poking, because since you are poking methodically, you don't know when to stop. Yeah, I think that with hash map, it's totally worth iterating over the elements already in the hash map. Like, well, we know already that it cuts a few iterations that way, but like also for my ergonomics, makes things easy. I see. Well, in any case, if yours take 300 milliseconds, that's already pretty good. I suspect that if you change it to my version, you'll probably be competitive with what we have here in Zig. You'd probably be closer to this. Also, by the way, it depends on what computer you have. For all I know, maybe this solution is closer to yours on your computer. I think I could run yours actually. Is it this stuff inlined? Oh, copy. Day17.go and the call it day17.txt. Oh, you know what? Also depends on your input. Your input might be slightly maybe different enough. Mine make a difference, maybe not, I don't know. I have my input. Okay, day17.txt. Is it go run? I try to do that always a lot of wasting time and keeping are on keeping track of the boundaries. It has a lot of necessary checks on our empty cell. Is go run good enough? No, I need to do go build, right? I want to time it. So go build day 17.go. Package AOC util IO is not in go root. Oh. Oh, what is this IO evil madness that you are using that I don't have? Oh, is this what the new paste bin is about? Oh no, that's your input. Okay, so thank you. Can you pass the code very quickly, or is it complicated? Like if you can make another paste bin, I'll paste into the main file and we should be good to go, right? Oh, it's just get lines. Yeah, if you can give me get lines, I'll paste it at the bottom. Also, in the meantime, let me try my stuff with your input so we can do a proper comparison. So ZBuild day 17 release fast. Hyperfine day 17. Yeah, it's about the same. 70 something milliseconds. Okay. Oh. OS buff IO. We have OS buff IO. We don't. OS, and is it IO slash buff IO, or is it directly buff IO? I don't remember. Okay, nice. Worked. Is there any flag for like release builds, or is this already a release build? Okay, yeah, takes double the time. There's also one thing that makes a difference actually between yours and mine. You are opening the file and parsing it in the application every time it runs, right? In my case, when I do this or when I do embed file, the file is loaded as a string, a global constant, and so the parsing happens at at runtime. Like this tokenized stuff happens in runtime. But at least we avoid opening stuff, and I think this takes a few milliseconds by itself. But yeah, I imagine it is slower. I benchmark it without I/O. How do you do that? What do you use to benchmark it without I/O? I see. Well, if you tell me how to benchmark it, if it's easy, if I have like the tools and I don't need anything else, I'll try to take a look. But I think I think we can safely say that it's roughly twice as slow. Um, I think that if you use the other strategy, you will get much closer. Also, if you spare yourself the hashing suffering and just go straight array map, that helps. Like this. Okay, I see. Oh wait, this is just part one. No, it's not really part one, or is it? Do you have a part two function, or do you just like make the modifications in place? Oh, I think you made the modifications in place. Everything looks four dimensional. Okay, so you call it part one, but it's actually became part two, right? Okay, yeah, you modified it. So we don't need get position, set position, or do we? Well, no, we do. It just becomes much more easy. Key is a for int. Key is a for int. Sorry, I want to try this. So this already should be nice. Line 49. Move W int. Oh yeah. So let's see. Is this an improvement? Well, if it compiles, yes. Too many arguments. There aren't that many places at the end of the day. I mean, yeah, there is a few, but hey, I'm the guy that decided to do a three-dimensional table. So this is not that bad compared to that. Wait, what did it do? Int. What? This is crazy. You were right. You were right. Using arrays makes it slower. That is indeed interesting. Why though? Does Go have something like? Is there like small ints that we can use somewhere? Like instead of int, something smaller, like the equivalent of a I16. Oh, int 16, yes. Okay. Whoops, sorry. Not of. I don't think that help. Let's see. Print 16F. Yes. Yes. Cannot use count. Type int 16. Type int as type int 16 in return argument. Var count int 16, right? Cannot use len lines by one type int as type int 16 argument to new pocket. What is the first thing that new pocket takes in? Max. But we can cast this stuff, right? How do you cast? Cast is it's just like int 16, right? Int 16, blah 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 blah. That's the same here. Oh. That does help. So we're back in business. And if we knew what, if we had a better idea of how many bytes, how many bits it took, like maybe int 8 is enough. I think that Go doesn't have int 8, does it? No, wait, it should have. Byte. So maybe that would work. Anyway, something to think about. In my case, oh, that's interesting. So let's go back. This gives an idea back for my case. So in my case, I made this I size. Everything here is an I size. What if these things shouldn't be I sizes? Let's make them I16s then. Is this gonna help me too?